Hello, everyone. My name is Leonid Shifrin, and I work in the Agent Connectivity Engineering group at Wolfram. And today we are going to talk about new developments in RLink, which has been the link that I was developing and responsible for, and which connects Wolfram language with the R language. Uh, so. Uh, has been first introduced in version 9, which was roughly 12 years ago in 2012. And since its inception, there hasn't been uh, that much new developments in RLink for a number of years, but in the last year approximately, we have added a number of experimental features which I'm going to talk about, and which hopefully will make work with RLink smoother and fill some of the gaps in the RLink infrastructure. To give a brief overview, because this talk is not intended to be any kind of introduction to RLink, so I'm assuming that you can use it or know how to use it, but I'll still give a few examples to sort of start. And I have 3 examples here. So the first example basically shows how you can define your own functions. Like the simplest function is you have some text, and the first thing you have to do is basically you need to load the package and call install R. And here is first difference with respect to how it used to work. RLink used to bundle its own R distribution, but we no longer do that for various reasons, although we are planning to bring this back in some form, but differently from how it used to be. And so install R with no arguments currently works differently. It automatically searches for available R installations on your system, and it tries to automatically configure those installations to be used in RLink. It's not always possible to do that automatically. If it's not possible, then there is a documentation of how to do it manually, but we are actually hoping that the number of cases where you will have to do manual configuration will be pretty small, like maybe a few %, and in most cases the system should be able to configure this for you, except possibly on Linux. On Linux you might actually need to do more of work yourself, but there is a documentation how to do that. So here is an example. You have some text, and REvaluate in this case will produce your R function, which is function we defined through its string code in our language, and then you can use this to split the text into words and return the result back in the form that RLink produces in the Wolfram language. So you can also do that using the external evaluate cell, although currently you can't choose. There is only a single R session running all the time, so it will always be a single R session that is currently running. This is going to be changed pretty soon, but right now RLink doesn't support multiple R sessions yet. So, and basically, doesn't matter how you define a function, you can use it as you would use any normal Wolfram language function now and return your results. So the second example is the plot and histogram of the chi-square distribution. So we here produce chi-square distributed random variables. And so this has been done in R. Now one thing you can do on the Wolfram language side, obviously using Wolfram language functionality to actually compare the histogram with the analytical form plot of this function. But this example shows how you can basically grab also graphics from R if you want to. Right now, RLink still doesn't support this sort of functionality out of the box, although I hope it will pretty soon. But basically, here, what we do to plot this in R, you have to set it to some variable in R. So this is a variable you're using to set this data in R workspace, and then basically we can plot this using R plotting capabilities and return the result back into Wolfram language. So this just illustrates. And the last example here is of different nature, where basically we want to query the SQLite database, and let's pretend we don't have other means of doing that. If somehow you want to do it through R, one thing you can do, so this is our sample file. This is a database which contains a bunch of tables which contain information about scaled models of cars being sold by some hypothetical company. And here is a new function that I'm going to touch soon in this talk, which is our install package. So this is a new dedicated function to install our packages. And so we install the RSQLite package. You can see it has been successfully installed. In fact, this was already installed. It tells you that. And then for the pre-14.1 version, you can still install packages, but it's less robust than this new functionality. And then you can actually load this package, and then you can execute the query. So basically what you do, you define a function RSQL execute, which does connecting to the database. So it takes file and the query, and then it returns the result, and it disconnects and returns the result. And then once you define it, you can call it with this file and with some simplistic query that we want to run. And you can see that this is the result returned by RLink. And another new feature that I'm going to touch soon is that dataset currently works at least with some, and this is a new thing, it works with at least some R data frames. So that you can see, unfortunately, this is that might be not very easy to see because of the scaling in this presentation, but you can see that there is a data set with this data obtained through this use of this our SQLite package and the querying of SQLite database on the R side. So these are the examples. Now, I will briefly go through this R session lifecycle as a reminder. So this is still sort of an overview. So basically, the standard workflow is that you first have to load the package, then call install R. Well, right at this point, it does nothing because it has been already installed. Then you can check that you have R running. So that this is a simple checks that I always do. I can query for version or home location. You'll see where the installation you're using is located. And if you, once you're done, you call uninstall R. Now you can also use a specific R location. What you typically have to do in this case, you have to provide the R home location option pointing to the home directory where your R installation is located. Now the well, in this case, it actually does nothing because apparently, actually no, it actually loaded because I called uninstall R. That's right, and then this will again return to us this. Now, in some cases, especially if you're configuring our installation manually, basically configuring our installation amounts to installing the R Java package on the R workspace, because this is a package that is internally used by RLink to connect, because RLink internally uses Java under the hood. So essentially, once you install it, you can install it using R command line. RLink tries to do that for you, but if for whatever reason it fails, then you can also do it yourself. And then one thing you might need to do is to indicate this location of this package so that RLink can work. Now, you can also use a specific JVM, but that's a more sort of technical thing. I'll simply mention it for completeness. And the other important thing is that the last successfully used R installation is cached. So basically, once you used it with the explicit R home location option, next time it will try to use that same installation unless you indicate explicitly that you want to use a different one. And so all the next or subsequent times, you don't have to specify our home location. It will use the last successfully used R installation to load into the R session. Right now, just to quickly remind that basically you need a running session to run any R code. So if I call uninstall R and try to run R evaluate or any other R evaluation function, this will fail. And also, if I try to run like install R on a a different R installation than the one that is already running, then it's an error because it only supports a single R installation running at any given time. This is going to change in the near future, but right now it still is like that. So basically, if you want to use another one, you first need to call install R before you do that. Okay, that has been the overview. Now, the new features. First, smallish feature which needs probably just a honorable mention, which is this data set with the our data frames interop, which is now being better, and it's experimental. It's not yet supported on all data frame shapes and in R. It's going to be included into 14.2, and it's going to be documented probably after 14.2. The examples can be, okay, in this particular case, I'm using the built-in empty cars dataset, which is built in R, and it is some sort of dataset about various cars. And once we do R evaluate on this thing, it returns to you a data frame. And this data frame, when you wrap it in dataset, you get a nicely formatted dataset. Right. So this round trip, so you can basically if you save it in a variable, then if you call our data frame on that variable, you get back the our data frame expression, which is suitable for sending back into our workspace. So it works both ways. Okay, now one bigger new feature that is actually not yet documented, and so it has an experimental status. It actually exists starting 14.1 version, but it's likely to be documented later, but I think it's still useful to show. It's the automatic functionality to discover and manage R installation. So you can call R installation find function, which is in the RLink namespace, in the RLink context, and the exact formatting and the typesetting of these objects will probably be changed, but basically each installation that the system is able to find, it will find it will form this sort of object, our installation object for that installation, and it contains a number of various properties for this installation, such as the home location, the version, and also it has flags like validated and configured. Essentially, validated means that it tried to execute some code using our command line and verified that it actually works, whereas configured means that it actually installed our Java package for it and has fully configured to use with RLink. So in this case, all these installations have been verified and configured. Now you can also limit the number of installations that you want to find here. And if you don't find your installation within the found ones, you can also register it using our installation register. And if you, for example, this is a separate one, which is not in the normal location where the system will look for it. And then if I call our installation find, you can also include only the ones which are cached, in which case there will be no search over your file system. It's faster, and it finds more because it finds also this one, and apparently it finds yet another one which was probably outside of the search for our installation find without the caching. And also you can use our installation object directly in install R. So basically now I'm uninstalling currently running R, and I'm using install R on this first found installation objects. and we can test that now it's actually completely different. It's the one that is living totally in a different place. So it's a different installation now. But the main point is that you will be able to use this R installation objects directly in our installer. Okay, so that's the feature that is going to be further developed and eventually documented. Now, another, yeah, and to return back to this one, there is also other functionality related to our installations. So basically, the system tries to configure installations immediately, but there is also a separate function R installation configure that does it manually. I decided not to show it here, but it will eventually be all documented. And so the configuration process, which is essentially building and installing this RJava package, is encapsulated in this function. So hopefully everything will be done automatically. Then the next step, which is slightly less convenient, is that you'll have to call this function manually. And if that fails, there is a documentation on how to automatically configure your R installation to use with RLink. But hopefully, again, you will not even have to call this one, let alone that documentation. Okay, now the next feature I wanted to describe is installing our packages. I briefly was showing that to you already in that first example. So this actually has been documented in 14.1. This is a new feature. It's still experimental. Let me show you the basic workflow for this. So let's say I'm returning back to this installation of R that I'm mostly using for these examples, which lives here. Now, let's say we want to install our SQLite package, which I was already showing before. So in this case, it says that it has been already installed, and it shows to you the home location for the R installation where it's installed and the path. What is actually important is that our our session doesn't have to be running for this to work. So unlike our evaluate, which requires our running our session, our install package will work even if there is no running our session. But in this case, it has certain documented sequence of things that will try to determine which R installation to use to install this package. Or you can also install explicitly for specific versions. So if I'm doing, let's say I'll do uninstall, I'm sorry, uninstall R. And if I do this, this will still work, and this will still use the same R installation because this has been the last successful use R installation. This is the first thing it will try. Yeah, I think it's important to know that our install package works independently of our evaluate or anything else, so it doesn't need to have running RLink session to work. Now, there isn't a separate command to uninstall package, but for that, what you have to do is to pass an option to our install package. Installation method goes to remove. And if you do that, it will remove the whatever package you want to remove. And then, well, for this one, actually, we will need to install R again because our evaluate, we wanted to check that this package has been indeed removed from the list of installed packages. For that, we will have to still have a running R session. So let's just install it and then call R evaluate of install packages. And you can see, well, if you inspect this package, you'll see there is no R SQLite package in here. Whereas if we now install it again, and then rerun this command after that, in fact, you can see here it also shows standard output. It shows some details of the installation. So, and if we look now, you can see the RSQLi package is now here. So our install package is a more robust way of installing our packages than just using our evaluate, and in a number of ways, and it's going to be further developed so that there are several ways in R how you can install packages, and hopefully we'll incorporate those other ways into our install package as well. You can also reinstall package if you want to do that. You pass reinstall to true. Let's actually try that. Now, the if you try, there are some, obviously you can face some errors. If you try to install some non-existent package, it will fail, and you can see this, that there is an error output, and if you expand the boxes, it will tell you basically what went wrong. In this case, it says that this package is not available because it actually doesn't exist. The other pretty important thing is you can also install packages from binaries or sources. So there are various reasons why it may be useful. For example, there is a timeout on installing packages, and if your package is really large, it may just be downloading pretty slowly, and so our install package on just the package name might fail, but then you can download the binary, like this RSQLite package, for example, and then you can install from the binary. You just need to pass options local source path, and in this case also reinstall, because we are reinstalling the package. And here we go. Right, so this is about installing packages. Now, another new feature, first of all, let me very quickly look in whether there are any questions. Syntax highlighting external language cell. Well, the ironic thing about this is that the very first version of RLink kind of had it already, even long before the external evaluate appeared. But yeah, we have some plans in general syntax highlighting for various languages, including also R. So, but that's a good suggestion. We will keep that in mind. Yeah, the question about external session register. Well, the thing about that is that RLink is sufficiently independent from external evaluates, so you will be able to do exactly the same thing also through external session register. That will be totally fine. But for those who actually want to use RLink on its own without external evaluate, they will have their own RLink based API that they could use, because basically external evaluate is just one channel of using RLink, and therefore it will be your preference how you want to use it, whether you want to use it through external evaluate or whether you want to use it directly through RLink. Okay, now our object references. So that's probably the last thing I'm having time to show. So this is experimental. It's still to be documented. And the motivation is that there are some R objects which are not directly importable into R. So I will skip the notes. I'll just show you how it's used. Let me just quickly look at, yeah, I don't have much time left. So basically this is going to be, there are two ways you can get reference to R for any R object. You can either pass to R evaluative option return type reference, or you can call R return as object reference and then whatever is there. In all cases, you'll get back what, like the object, the expression of the head R object reference, and then in order to evaluate it, you need to actually call R evaluate on it, and it dereferences that. So basically, you can create the references from any objects, including even primitive types, and then you can pass them. You can even return function call result as a reference. So in our function, for example, you can pass the same option and then return you return the result as a reference. To do reference, you basically just call revalidate. And then, okay, let me just show this quickly. Now you can use references pretty much almost everywhere where the normal RLink expressions can be used. So you can pass them into functions. You can set them into our workspace. You can return them, or can return functions as references. So in this case, sum is a function, but we still return it as a reference. You can use it in other functions like this. You can assign this function to our variable and then use it like this. Now, there is some resource management associated with that you need to basically delete the references you no longer use. That is going to be probably changed at some point. There will be some automatic garbage collection of these references, but it's not yet the case. And if you are trying to use invalid references, you will get an error. So I will probably have time to show just one example. I just don't know why it is hidden. Basically, for the SQLite, we already have this library installed. So before, in that initial example, we were doing this. We had a function, we executed, we had a query. But now with the references, you can do more. You can basically define two functions, connect and disconnect. And connect essentially creates to you connection as a reference. And then what you can do, you can basically define a function which will use this connection and execute the query of your liking using that connection, and then you can disconnect. So this is something that wasn't really possible without the references, but now it is. Okay, let me just, I won't have time because I'm actually running out of time. So I won't have time to show our virtual environments. This is an experimental feature which is going to be documented after 14.2, and which is very, very experimental. But basically, we are trying to use the Anaconda/Miniconda capabilities to provide provision R, and you will be able to use to create your own R virtual environments and then use those environments. But I have no time to show these examples. In the slides that I have submitted, there are these examples with full output, so you can look at how they actually look. And so the roadmap and next steps are these. So we need to still support multiple R sessions in RLink. We need improvements for our virtual environments. They are not yet fully integrated, and they're pretty slow to create. We need improved integration with external environment, and there is this external session and all other things, so that if you prefer that, you will be able to use RLink through external evaluate. We will have to support more data types out of the box, like what we did for dataset, but also for tabular, for plotting, and for other common data types. And we'll need better error handling than it currently exists, so that there are some cryptic error messages that we want to improve. So that has been this overview. Thank you. And let me go back and see if there are any. Yeah, there are two questions in Q&A, which I hopefully answered. Right, so for the syntax highlighting point taken, and we definitely will look into that. Yeah, so that has been my talk, and the new features, let me just quickly list them again. So these are essentially our package installation, our object references, our installation and discovery and management, and our virtual environments. These are the four main features that are new and have been developed over the last year. So thank you very much, and please, if you have any questions, we still have time to answer, although my talk is officially over, but I can still answer questions if there are any. Thank you very much. Okay, so there was a suggestion to support plots. Yeah, this is something we definitely will look into.